Now solution to engineering mechanics, problem set 2.7, solution to 2.111. Let me read out the statement. A solid right circular cone of altitude h, this OAB, is a right circular cone, means the base is circular. The base of the cone is circular, and O is the vertex. O is the vertex. Why it is called right circular? From the vertex, if you join this line, the line joining the vertex and the center of the base, which is circular, and this line is perpendicular, is normal to the base, means with the radius of the base, this makes angle 90 degree, therefore it is called right circular. The radius is given as 76.2 mm, has its center of gravity C, means from the center of gravity, and the weight of the cylinder is acting vertically downward due to the pull of the earth. On its geometric axis at a distance h by 4. The center of gravity from the center of the circular base is at a height from here to here is h by 4. And that is also given as 76.2 millimeter above the base. This cone is resting on an inclined plane AB. As you can see, this is the inclined plane AB, making angle 30 degree with the horizontal. Making angle 30 degree horizontal, for which the coefficient of friction, the value of mu, is given because the right circular cone is resting on the inclined plane, so this cone will try to move to this side, will tend to slide to this side. So the force of friction at the bottom of the circular cone, the force of friction will be to this side. And the coefficient of friction is given as 0.5. Now what is happening? A horizontal force P is applied. At the vertex O, a horizontal force P is applied and acts in a vertical plane of the figure as shown. Find the maximum and the minimum value of the applied force P consistent with equilibrium of the cone if the weight of the cone is given as 44.5 Newton. So I have to redraw the diagram and explain you different forces. Now, well, you can see the height of the cone is given, that is the length from the vertex O to the center of the circular base. The base is circular. From the vertex O to the center of the circular base is given as 304.6. The radius is also given. And the height of the center of gravity from where the weight of the cone is acting vertically downward is also known. Both R and H by 4 are given equal. Now, so there is a redrawn diagram for you. Now look from here, the center of gravity, the weight is acting vertically downward. So, and this angle is given as 30 degree. So the component of W to this side will be, this is 90. In this triangle, this line is perpendicular to the horizontal, so this is 90, this is 30, so this will be 60, so this will be 60. So since this is 90, so this will also be 30. This angle will also be 30. Let me write it here. This angle is equal to 30 degree. So the component of W to this side will be W cos 30, means a component of the weight W is pushing this inclined plane to this side with a force W cos 30. That is one of the action force. And we will find out another action force also and we'll find out another action force also. So W cos 30 is one action force, that is a component of W, that is normal to this inclined plane, and P sin 30. And P sin 30 will also be normal to the inclined plane. So the total action force will be W cos 30 plus P sin 30. Now, so W cos 30 and P sin 30 act in the same direction as action force normal to the inclined plane AB. So the reaction force, so the inclined plane will provide equal and opposite amount of reaction force by Newton's third law of motion. So Rn is equal to W cos 30 plus P sin 30, normal reaction. And since the cone is tending to move to this side, here the force of friction, and force of friction, as you know, mu times normal reaction, so force of friction will be mu times Rn. And now look here, I have taken this as your x-axis and this line as your y-axis to show you the different orientations of different forces here. This is your x-axis, this is your y-axis, W is acting vertically downward, P is horizontal, and this angle is given, this angle will be 30 degree. Why this will be 30? Now if you look, this y-axis is perpendicular to x-axis here, means this whole angle is 90, this angle is 90. Again P is horizontal and W is vertically down, then this angle is 90. So between this 90 and this 90, this much is common. If you take out that, then we are left with equal angles. Since this is 30, therefore this will also be 30. Now, or you can do it in a different way. If you extend this line, then this will be 30, being vertically opposite to this 30. Y-axis is perpendicular to x-axis. So this is 30, so we are left with 60 here. Now, then with this line, this P makes 90 degree. This much is 60, so we are left with 30 here. That is the other way to explain it. Now, since this is P, so to this side will be your P, to this side will be your P times cos 30, and to this side will be your P times sin 30. So P sin 30 is also normal to the x-axis, and W cos 30, the component of W, will be to this side. W cos 30 will be also perpendicular to xx dash, and xx dash is the plane on which the base of the cone is resting. So P cos 30 plus, P sin 30 plus W cos 30 at this point, that is same thing as this point, is acting to this side, that is the action force. So the normal reaction is along positive y-axis. So the normal reaction is along positive y-axis. Now once that is known, so let us apply sigma y is equal to 0, means sum of the forces along y-axis is equal to 0. That is, normal reaction Rn will be P sin 30 plus W cos 30. So applying sigma y is equal to 0, we get normal reaction W cos 30 plus P sin 30. The cone is trying to slide down along BA. This cone is trying to slide along the direction BA. So the force of friction is to this side. which I have shown it here. And since force of friction F is mu times the normal reaction Rn, is therefore acting along AB, opposite to the direction in which the cone is trying to slide. So P sin 30 along AB. Now P sin cos 30 and F is equal to mu are in the same direction. You can see it here, P cos 30. This is your P, so to this side will be your P cos 30 and mu Rn. They are in the same direction. Now apply sigma x is equal to 0. Sum of the forces along x-axis. Now this is your x-axis, positive x-axis, this is your negative x-axis. So mu Rn and P cos 30. Mu Rn, P cos 30, they are along positive x-axis. And W sin 30, if you look at here, again, this is your W. So this part will be, this part is same thing as this part, that is in front of the angle, it will be W times sin 30, which is opposite to the direction of mu Rn and P cos 30. So, W sin 30 is along negative x-axis, mu Rn, P cos 30 is along positive x-axis. Now put the value of Rn from equation 1, put the value of Rn from equation 1 here. So mu times, this is the value of Rn, P cos 30 remains as cos 30 is equal to W sin 30. Now just multiply, take mu inside, mu W cos 30, mu P sin 30, P cos 30 is equal to W sin 30. Now mu P sin 30 is here and P cos 30 is here. Take this term to the right hand side. So this becomes W sin 30 minus mu W cos 30. So that we can take mu common. Now from here I can take P common. So I am left with mu times sin 30 plus cos 30 is equal to W is 44.5. W is taken common, sin 30 1 by 2 mu 0.5 times cos 30 root 3 by 2. So if you take these terms to the right hand side, it will be divided. So we get P is equal to 2.67 Newton. So this is the maximum. So this is the maximum applied force P that you are applying horizontally to the vertex. So this is the minimum value of P when the cone tends to slide. When the cone is about to slide down the inclined plane along BA, this is the minimum value of a P. Now the question is, now if the cone tends to topple at B, then we have to take the moment of the forces. If this cone is trying to topple like this, means its base will leave contact with the inclined plane in that situation, toppling. Now, if the cone tends to topple at B, sum of the moments about point B is 0. That is to make turning effect for different forces about B is equal to 0. So we have to take the turning effect of different forces. Now let me explain you once more. R is the perpendicular distance of W cos 30 from point B. Now look at where is W cos 30. This was your W. This is your W sin 30. This is your W cos 30. W cos 30 and W cos 30 to this side from the point B. This is the line of action of W cos 30. this line of action from the point B is at this perpendicular distance, that is radius of the base. So R is the perpendicular distance of W cos 30 from B. H by 4 is the perpendicular distance of W sin 30 from point B. Now, where is W sin 30? Now, this is W, this is your W sin 30, but you have to show this W sin 30 from the center of gravity, from where the weight is acting. So, to this side is your W sin 30, this thing, that is same thing as this. From the point B, it is at a perpendicular distance h by 4. So, h by 4 is the perpendicular distance of W sin 30 from B, and R is the perpendicular distance of P sin 30 from B. Now, if you look at point P sin 30, that is same thing as this is your P. So this part, that is same thing as this. P sin 30 from the point B is at a perpendicular distance R. So all these things will produce an anti-clockwise movement about point B. And H is the perpendicular distance of P cos 30 from B. So this will produce a clockwise movement. So let us make them equal. So R times this plus H by 4 times this plus R times P sin 30 will be equal to H times P cos 30. So that is what I have written. W cos 30 times R plus W sin 30 times H by 4 plus P sin 30 times R will be equal to P cos 30 times H. Now simple, just put the values. W cos 30 R and W sin H by 4. Take this, turn to the right hand side, it is subtracted. Now, now take a W common from here. So cos 30 times R plus sin 30 times H by 4, P cos 30 times H minus sin 30, P is taken common, times 76.2, that is the value of R. Now put the value of W which is given and put all these things in a scientific calculator. You get P as equal to 20.5238 Newton. So that is all about. It's an interesting problem. If you feel comfortable with the explanations, you can give back your comments, and if you like, you can subscribe and pass on to your friends pursuing engineering mechanics as a subject in different engineering courses. And if you are preparing for GATE also, thank you.